Can message me. Okay, see that was the parallax method. Okay, so in parallax method is used to what? It's used to find the distance between the Earth and the Sun. Any distance we have to find. Now, what is parallax method? I told you about parallax that when you change the observer, when you change the observing point, the location of the shift of the point, tip of the point is known as parallax method. Okay. Now, this parallax method can be helpful for us to find the distance between the Earth and the Sun, okay, Earth and the Moon, or any other heavenly bodies. Okay, for that, what we have to do? See, let us suppose that we have a moon. Okay, so this is the moon, and we have to find the distance of the moon from the Earth. Okay, fine. Now, this is the Earth. Now, we know that Earth and moon are separated at a very larger distance. Now, when they are separated at a very larger distance, then 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 what we have to do? Then we have to change the point of observation of the Earth and the Moon. Okay, so first of all, we have to observe from point A, then we have to observe from point B. Okay, now we have to observe some point C. So from here, this from point A, the point C would be located at some angle theta, some angle theta 1. Okay, and point from point B, the point C is located at some angle theta 2. Okay, fine. Now A and B are the diametrically opposite point, which means they are located on the opposite end of the earth. Okay, so if A point is here, then the B point would be diametrically opposite point, which means the distance between A and B will be capital D. Okay, which is the diameter of the earth. No, I think it is only for NEET student. Tomorrow it will be for JE students. Okay, 11 JE student. Tomorrow it will be the class. Okay, now let us suppose that the total angle is theta. This total angle is theta. Okay, the distance between the earth and the moon is say small d. Okay, now you remember one thing that the angle theta, if you remember the concept of arc, plane angle theta, then I told you that plane angle theta is equal to arc by radius. Okay, now if you consider this, radius is the distance between the sun and the moon, earth and the moon. This is the moon, this is the earth. Okay, the distance between earth and moon is d, small d, and the arc here will be capital D. Okay, why it is a capital D? Because this this earth and moon are located at a very large distance. When they are located at a very large distance, this arc becomes a straight line. Okay, like one more example I can give you. Like if you look at the, if you know that we are on the surface of the earth. Okay, we are on the surface of the earth. Fine. Now now by observing from the earth surface, can you think that the earth is a flat, or earth is a spherical in shape? We know it is spherical in shape, but when we are observing from the ground, we will find it is flat. Why it is flat? The reason is that this radius is very large. If this radius is very large, the arc which we can observe would be like a straight line. Okay, so why it would be like a straight line? Because the radius of the earth is very large. Okay, the same example here, that if the distance between earth and moon is very large, then this arc becomes a straight line. So if it is a straight line, can we say theta equal to d by small d? Okay, or from here we can get the distance d, that is equal to diameter of the earth by angle theta. Now this theta should be in radians. Okay, and d is the diameter of the earth, which we know. Fine. Why radius is d? See, if you think on this point, we are observing from point A to point C. Distance between them is d, and from point B to point C, it would be d. Okay. So here D is the, you can assume like this is the radius, D is the radius, and this is the arc length. Capital D is the arc length. Okay. Yes, distance between the two objects is D. Yes, distance between the two objects is D. JE class is for tomorrow. 11 JE dot clarification class is tomorrow. Okay. D is the diameter of the earth. Capital D is the diameter of the earth. D is the distance between the earth and the moon. And theta is the angle. Now how can you measure the angle? D by 2 will be the radius. So if a radius of the earth is given to you, then capital D will be equal to 2r. Fine. Okay. So capital D will be equal to 2r. Here, D I am telling you about the arc length. This D is the arc length. See, here I given a formula. Arc, this is the arc length. This is the radius. Small d is the radius between the earth and the sun, earth and the moon. The radius here will be small d. Capital D is the arc length. Arc length is capital D. Okay, fine. Did you understand, Jivita? Yes, yes. See, this rule, this rule which I am telling you, this rule, this rule comes from the arc length only, na? That theta is equal to arc length by radius. Now, if the distance between, if the arc length is very large, see, if you just tell me one thing, okay, if the if the circle is small radius, then you will find that arc length will be more or not. Okay, the distance arc length will be more. But if I make a very large circle and same angle theta if I make, then this arc length would be like a straight line. Okay, so this will become a straight line. So if you just think like this is the radius r and this is the arc length. Okay, this is the arc length. Fine. So this angle is theta. Correct. Now arc length is a straight line here because this distance between earth and moon is very large. That is why. Okay. See, 11 JE dot clarification class will be tomorrow. Okay. Today is for 11 NEET. Fine. Doubt clarification class means I will not teach you anything. Whatever doubt you are having, you have to ask me. Okay. Okay. Any other doubts in kinematics 1D which I am teaching you or unit dimension? Any other doubts you are having? Any other doubt in any other chapter, any other point, you can ask me. 27 slide. Wait, this one. Which problem? Today graph. Okay. See, if you look at this graph, fine. Now, what is average velocity? Average velocity is the total displacement by total time taken. Average velocity is total displacement by total time table. So we have assumed one condition here. Okay, we have assumed one condition here that let at time t1 the particle was at x1 meter, and at t2 the particle was at x2 meter. So what was the displacement of the particle? That is x2 minus x1. Okay, we are putting arrow here. Arrow represent what? The vector form. Okay, so x2, if I put arrow here, it means it is a displacement. Okay, arrow means it is a displacement. Okay, so what is average velocity? Average velocity is net displacement by time taken. So x2 minus x1 by t2 minus t1 is the average velocity. Now if I plot these point on a graph, okay, now if you look at this graph, we can assume that at t1 the displacement was x1, at t2 displacement is x2. So we can assume the point p1 and p2, which represent these 4 points. Okay, x1, x2 and x3. now now if I plot this point, then I found that what is displacement? Displacement is the shortest distance between the initial point and final point. Okay, so x2 is here, x1 is here. What is the shortest distance? Shortest distance is a straight line joining x2 and x1. Okay, a straight line joining x2 and x1 is the displacement. Okay, sorry, p1 and p2. The straight line joining p1 and p2 is displacement. And direction of displacement, the direction of displacement would be from P1 to P2. Okay, I told you that this arrow represent what? This arrow represent what? That the particle is moving from head to tail. This is the head, this is the tail. So displacement from P1 to P2. So here displacement is from P1 to P2. Yes, direction it will show. Okay, now what is the average velocity? Average velocity we can write here as x2 minus x1 by t2 minus t1. Okay, now this is the average velocity, v average. So we can write as delta x by delta t. What is delta represent? Displacement. Okay, x2 minus x1 is displacement. Delta represent displacement here. Now if you remember this differentiation, I told you that a line joining p1 and p2 is the secant to the curve. Okay, fine. The line joining or the line which is cutting a graph into 2 points is known as secant. Okay, so if I draw the secant between P1 and P2, then the slope of the secant. Now how to find the slope of the secant? I told you the basic point that to find the slope, we have to look at the horizontal line. Okay, horizontal line. From horizontal line, we have to move to the anti-clockwise direction with angle theta. Okay, now we are moving with anti-clockwise direction with angle theta. Fine. Now if I draw the triangle here, the triangle P1 O P2, then what is PO length? PO length will be equal to x2 minus x1. And what is P1 O length? That is T2 minus t1. Okay. Now if I find tan theta will be equal to what? X2 vector minus x1 vector by t2 minus t1, which is delta x by delta t. So what we can say? Tan theta, or we can the slope. We can say the slope m. The slope m, the slope of secant will be equal to velocity average velocity. Okay. So average velocity can be found by drawing the secant to the curve and finding the slope of the secant. Okay. Now next is instantaneous velocity. Now instantaneous velocity means what? Instantaneous velocity means if see if I decrease the time interval, means t2 minus t1, we are decreasing time interval. Like in this case, see, average speed case, what I was doing here. First I found the average velocity. Okay, for 4 hours. For 4 hours speed was 100 kilometer per hour. Then I found for 1 second. Okay, then I found for then I found for 1 minute. Then I found for 1 second. Then I found for very small time interval, that is 0.001 second. Okay, now this 0.001 second. Okay, now if I find delta t here, what will be delta t here? That would be equal to 0.0001 minus 0, which is 0.0001 second. This interval is so small that we can say that the displacement of the particle at 11 a.m., because the interval of the time is very small. You can see 0.001 is a very small interval. Okay, so if I reduce the interval, then I can find the velocity of a point and velocity of a body at a particular instant of the time. Okay, so what is the instant of the time? In this case, 11 a.m. Okay, so how we can find the instant of the time? If I reduce the time interval. Okay, now in this case, if I have to find, see the same graph I am using here. Okay, if I have to find the velocity at time t1, if I have to find the velocity of the body at time t1, then what I have to do? This is the t1 point. Okay, so at t1 displacement was x1. This is the displacement x1. Fine. Now if I have to find the velocity at t1, what I have to do? I have to reduce the time interval. Okay. Now the interval of time is very small. We can say this is the interval of time, very small interval of time. Say t1 delta t. Okay. t1 plus delta t is a very small interval of time. During that small interval of time, we can see that how much displacement is there. Only very small displacement delta x is there. Okay, fine. So from here we can say we can say one thing, that if I draw the straight line, if I draw a secant to this point t1 point, then that secant will become tangent to the curve. Okay, that secant will become tangent to the curve, and the slope of that tangent will give us the instantaneous velocity. Okay, so instantaneous velocity is the slope of the tangent at time t1. Similarly, if I have to find for t2, what I have to do for time t2, what we have to do? I have to bring this t1 time interval close to t2. Okay, then I can find what? I can find the velocity of the particle at t2 time interval. Okay, so velocity of a body at any instant of the time is basically the slope to the curve at that point. Okay, fine. Now the velocity v is represented by dx by dt, which means derivative of x with respect to t. Okay, I think this also I have explained to you when I was teaching you differentiation. Okay, fine. See, you don't require this. Okay, I just told you to understand the concept. Simply what you can do, just remember that the slope the slope of a tangent. Okay, the slope of a graph, or the slope of the tangent will represent the instantaneous velocity. This only you have to remember. Okay, fine. Like if any graph is given to us like this, see, just think that if any graph is given like this, we have given some graph. If I ask you, find the velocity at this point, so what I have to do? I have to draw the tangent at this point. The tangent will give the velocity at this point. Say, if I have to find velocity at this point, again I have to draw the tangent. Here, see, Again I have to draw the tangent. So the slope of the tangent will give us the slope of tangent give us velocity instantaneous. Okay, or we can represent only v represent instantaneous velocity. Okay, did you understand this or not? You don't need to remember the concept. Okay, just remember this thing that any graph is given to us, displacement versus time graph is given to us. The slope of the displacement versus time graph will give us the velocity of the body at that time. Any other doubts? Any other doubts are there? You can ask me. Okay, you can ask me. I don't think you are having a doubt, any doubts. This week you will have the exam of motion in one dimension. Okay. So if you have no doubt, any other problem in weekly test, if you don't have, if you cannot answer any problem, you can ask me. Any other doubts? Okay, I think you don't have any doubts. You can ask. Okay, screw gauge. Screw gauge, I have told you 2 or 3 times. I have told you screw gauge. Okay, just wait. I have to. Okay, okay, wait. I have to change my slide now. Wait. Okay, see. Okay, just wait 1 minute. Okay, so you can look at the screw gauge here. Fine. We have a. You can first of all let us see this construction here. We have a U-shaped frame. Okay, in the U-shaped frame we have an anvil which is fixed. Anvil cannot move, and we have a spindle. Okay, then with the U frame we have attached a main scale. This is the main scale. Over the main scale we have the circular scale. Fine. We have a thimble, and then we have a ratchet. Now ratchet is at the back of the screw cage. Okay. Now, now if I have to measure something, okay, like if I have to measure the length of the cylinder like this. Okay. So what I have to do, I have to place the cylinder between this anvil and the spindle like this. Okay. So when if I have to place the cylinder between the anvil and the spindle, what I have to do, I have to rotate this ratchet. Okay. So that I can adjust the gap between the spindle to perfectly fit this cylinder like this. Okay. Now when you're rotating this ratchet, what happens? This circular scale will rotate on the main scale, as well as it will move on the right side. Okay. So it will have two different motions. One will be the rotation of the screw gauge like this. So when you rotate the ratchet, the circular scale will move, rotate, as well as move along the right hand side. Okay. Fine. So let us suppose that we place a cylinder like this. Now you can see that in this particular cylinder, in this particular scale, we have 100 divisions of circular scale. Means circular scale is divided into how many divisions? 100 divisions. Okay, fine. It is divided into 100 divisions, which means if you completely rotate this circular scale, how many divisions should rotate? 100 divisions. So after 100 division, again reading will come as 0. So it will have its reading will start from 0 to 100, means 99. From 99 to 100, it becomes again 0. Okay, which means it has completed one complete rotation. One rotation. Okay, fine. It has one rotation. Now, now, see. Now next thing is that if we are not measuring anything, if you are not measuring anything, what will happen? This anvil will be in contact with the spindle like this. Okay, this anvil will be in contact with the spindle. Now in that case, if the instrument is perfectly fine, then the 0 of the main scale, this is the main scale, okay, this is the main scale, this is the circular scale or screw gauge, okay, this is the reference point, okay. Now the reading of the screw gauge or circular scale will start from there, 0, 1, 2, 3, 4, 5, like this, and at the back reading would be there, then from the back it will come as 95, 96, 97, 98, 99, then again 0. So if you are not measuring anything, then the 0 of the circular scale will exactly coincide with the reference line. Okay, it should exactly uh, coincide with reference line, and the 0 of the main scale should be visible to us. Okay, so this will be the perfect instrument. Okay, so this is the perfect instrument where 0 of the 1 year scale, sorry, 0 of the circular scale coincide with the reference line. This is the reference line. You can see this is the reference line. Reference line. Okay, fine. So this is the construction here. Fine. Now this instrument has no zero error. Okay. Now if I have to measure something, what I have to do? I have to place between the spindle. So when you place between the spindle, this circular scale will rotate and it will move on the right hand side. After moving on the right hand side, you will see that you will see that you will get some reading like this. You can see the reading here. If I zoom this figure out, see, you're getting some reading or not. This is what? 0.0, then it is 1 millimeter, 2 millimeter, 3, 4, 5, 6, 7. Like this, we have the reading like this. Okay. Now this is visible to us, which means this is the main scale reading. Okay, which is visible to us. Now you have to look at the coinciding part. Now we can see there here that this is the 10th reading. Okay, this is the 10th reading. So this is the 10th, 11, 12. This is the 12th reading. Okay, so we can see the 12th reading is coinciding with the reference line. So 12 will be your circular scale reading. Circular scale reading will be 12. This is the main scale reading. Okay, so the measured value will be equal to main scale reading plus circular scale reading into least count. Okay, so main scale reading which we can see here, this is the main scale reading. See, this is the main scale reading which we can see. Circular scale reading is 12, least count we can find. Okay, so in this way we find the measured value. Correct now? This is how we find the measured value. Now, now we have to find the least count. First of all, we have to find what? The least count of the screw gauge. Now, least count of screw gauge is defined as that when you start from 0 like this is the perfect instrument. When the 0 of the main scale is visible to us and 0 of the circular scale is coinciding with the reference line. Now, if you rotate this ratchet, okay, so what will happen? The circular scale will rotate. When it will rotate, it will move on the right hand side also. Yes, it will move on the right hand side. So after one complete rotation, how much it has displaced on the main scale? That is the pitch of the instrument. Okay, so when you completely rotate one time, after completely rotating one time, what you will observe? You will observe that you will find the reading of the main scale at 0.1. Okay, this is the circular scale like this. Fine, and this again 0 will come here. Okay, now you can see that how much it has moved, how much it has moved on the linear scale, how much circular scale has moved on the linear scale. That is the pitch. So if you take a normal scale, normal 1 year scale, normal main scale, it would have moved 1 millimeter. That is the pitch. So we can say pitch is basically one main scale division. Pitch is one main scale division, which will come as 1 millimeter divided by number of division, which is 100. So which will come as how much? 1 into 10 to the power minus 3 millimeter is the pitch of the instrument. Okay, so in this way we can find the pitch. So I think you understand what is pitch. Pitch is that after one complete rotation, how much the circular scale has displaced on the main scale. That is the pitch. Okay, so if you rotate the circular scale one time, how much it has displaced on the right hand side. That is the pitch divided by number of division. So if you take a normal, means if you take a normal standard screw gauge, then then the pitch would be equal to 1 millimeter. Standard screw gauge, it may be possible that it may change, but if I am speaking about the standard thing, the standard would be only 1 millimeter. Okay, so 1 millimeter by 100, that will come as 1 into 10 to the power minus 3. That is the that is what the least count of the instrument. This is the least count. So we found the least count. Okay, we found the main scale reading, circular scale reading. We found the main scale reading. Okay, so measured value will be equal to main scale reading plus circular scale reading into least count. This is the measured value. Now there is possibility that the instrument may have error. Okay, now when can you see the error? See, when the zero of the main scale coincide with the zero of the circular scale. So this instrument has no zero error because the zero of the circular scale is coinciding with the reference line. This is the reference line. Okay, so no error. Now, if the zero is below the reference line, then it becomes positive error. If it is above the reference line, then it is a negative error. Okay, to find the value of positive error will be equal to what? Coinciding part. So which is the coinciding part here? 0 is not coinciding, 1 is not coinciding, second is coinciding. So 2 into least count, which is 0.001, which is 0.001 millimeter or centimeter. Okay, this is the positive error. Negative error, to find negative error, that is equal to total number of divisions. So in this case, what is the total number of divisions? 50 divisions are there. You can see here 46, 47, 48, 49, then 50. But when it comes to 50, it reading again comes to 0. So how many divisions are there? 50 minus coinciding is 46 into least count. That is 4 into 0.001 centimeter means 0.004 centimeter is the least count. So to get the true reading of anything, true reading will be equal to measured value my measured value minus positive error. So if you subtract the positive error from measured, if you subtract positive measured value, positive error from measured value, we'll get what? Okay, true reading is measured value minus positive error. In case of negative error, true reading will be equal to measured value plus negative error. That is the true exact reading which we'll get. Okay, I hope you understand screw gauge. Okay, so I think you don't have any doubt. So can we end the season now? Can we end the meeting now? Okay, thank you all.